Okay, in this lesson we're going to be looking at Unit 8, Chapter 11, Permutations, Combinations, and the Binomial Theorem. We're looking at combinations and simplifying expressions and solving equations involving the C of n choose R. As we said, the main focus here is going to be on solving equations that involve the C of n choose R notation. I want you to recall the formula for the C of n choose R is equal to n factorial over n subtract R factorial times R factorial, recognizing again the restrictions. N has to be greater than or equal to R, which has to be greater than or equal to 0. N choose R is the same formula. N factorial over n subtract R factorial times R factorial. Same restriction. And recall as well the P of n choose R is equal to n factorial over n subtract R factorial. Let's jump right into some examples here that involve the C of n choose R. Solve for C of R. Now let's look at the first example here. We have the C of n choose 2 equals 28. C of n choose 2, writing that using our formula for the C of n choose R is simply n factorial over n subtract 2 factorial times 2 factorial equals 28. If we look at the n factorial and the n subtract 2 factorial, you recognize that I can break down the n factorial until I get to n subtract 2 factorial. So I would write that as n times n subtract 1 times n subtract 2 factorial. I stop there because my denominator has an n subtract 2 factorial in it as well. That enables me to cancel the n subtract 2 factorial. And now to continue with the simplifying here, I end up with n times n subtract 1 equals 28, and I'm going to cross multiply here and write 56, because 28 times 2 factorial, which is 2, is 56. So I got n squared, subtract n, subtract 56 equals 0. Let's factor this. I got n, 8, and 7, negative 8 and positive 7. It's correct factors here. So I end up with two values for n. I end up with 8 is equal to n is equal to 8, and n is equal to negative 7. I want you to remember the restrictions on n and r here. Here, n, remember, has to be greater than r. N can't be negative 7. N also has to be an element of natural numbers, and it isn't. The only correct answer here is n is equal to 8. N cannot be less than r. R is 2. So we have to reject this answer. The only correct solution is n is equal to 8. And you can double check that on your calculator if you wish. Do this C of 8 choose 2, and you should get an answer of 28. Let's have a look at B. B is an interesting question. It's more difficult than it actually looks. If we try and do this algebraically, which of course is what you would try and do here, we would get 7 factorial over 7 subtract r factorial times r factorial equals 21. I want to simplify this. I guess what we could do here is we can cross multiply and get 7 factorial equals 21 times 7 subtract r factorial times r factorial. I guess I can divide both sides by 21 now. And I'm left with 7 factorial divided by 21. If you do that on your calculator, you will get 240. So 240 is equal to 7 subtract, whoops, sorry, let me fix that. 7 subtract r factorial times r factorial. This creates a bit of a problem for us because we can't solve that algebraically. Because I got a 7 subtract r factorial times r factorial. I suppose I could divide both sides by r factorial and just plug in numbers. But I can plug in numbers here as well. The only way to correctly solve this now is to actually choose values of r, plug them in, and see which values of r will solve this equation. Of course, we could have done that in the original equation as well. I could choose values of r here and substitute in, use my calculator, and see which values of r would give me 21. Now remember, there are restrictions on the value of r. So it's not like we're trying every possible value of r. Remember, r has to be greater than or equal to 0, but yet it has to be less than or equal to 7. That's the restriction on r. So the only possibilities for r are 0, 1, 2, 3, 4, 5, 6, 7. But I know a little bit of information here about r. that will enable me to narrow this down even further. I know that the C of 7 choose 0 is actually equal to 1. I don't need to try 0 because I know that's not correct. I also know that the C of 7 choose 7 is also 1. I don't need to try 7. Now again, you may not know that, and you may have to try these numbers, but I know that, so it eliminates some of these possibilities that I need to try here. I know that the C of 7 choose 1 is 7. I know that the C of 7 choose 6 is also 7. So I've eliminated 4 of the 7 possibilities, or 8 possibilities that I need to try, the numbers 0 through 7. I've eliminated 4 of them. So maybe I could try the C of 7 choose 2. Take your calculator and do that. You should be able to use this on your calculator now. The C of 7 choose 2, you press 7, math button on your TI-83, go over to probability, the C of n choose 2, and 7 choose 2 gives me D21. So one possible answer for R is 21. Sorry, one possible answer for R is 2. One possible answer for R is 2. But is that the only possible answer? Well, there's a bit of a pattern created here. 7 choose 0 and 7 choose 7 are both equal to 1. 7 choose 1 and 7 choose 6 are both equal to 7. So is there another possible answer that will equal 21? And the answer is yes. The C of 7 choose 5, if you check it on your calculator, will also be 21. So R could equal 2 or R could equal 5. So there are 2 possible answers here. Now if you want to double check it with your expression down here, we can check it from here as well. Let's check if R is equal to 2. I get 240 equals 7 subtract 2 factorial times 2 factorial. 240 should equal 5 factorial times 2 factorial. 240 should equal 5 factorial, which is 120, times 2. That works, doesn't it? And if I check R is equal to 5, I get the exact same answer. And that will work as well. The only way to solve this is to actually use trial and error and plug in values of R until you get it to work. Because I can't solve that algebraically there. The P of 7 choose R equals some number, we can do it algebraically. But the C of 7 choose R, we can't. Interesting question. Let's move on and try to C part over here now. N plus 1 choose 1 equals 20. That becomes n plus 1 factorial over n plus 1 subtract 1 factorial times 1 factorial equals 20. Simplifying, I get n plus 1 factorial over n factorial times 1 factorial, which is 1, equals 20. Now at this point you want to break down one of the factorials so that it will cancel with the other one. You always start with the larger of the 2 factorials. I get an n plus 1 and an n. N plus 1 is larger than n, so I break that one down until I get the next factorial. Until I get the factorial that I want in my denominator. So n plus 1 times n factorial will cause the factorials to cancel here. And I'm simply left with n plus 1 equals 20, so n is equal to 19. N is equal to 19. Done. Let's try another example here. Express as factorials and simplify. Express as factorials and simplify. It's the C of n choose 5 over the C of n subtract 1 choose 3. So let's simplify here. It's n factorial over n subtract 5 factorial divided by n subtract 1 factorial over n subtract 1 subtract 3 factorial times 3 factorial. This becomes n factorial over n subtract 5 factorial times, I'm going to bring my n subtract 1 factorial down here in my denominator. In the numerator, n subtract 1 subtract 3 is n subtract 4 factorial, isn't it? Times 3 factorial. And I left out a 5 factorial here, I think. And in fact, I did. And be careful with that. It's n factorial over n subtract 5 factorial times 5 factorial. I put it in here, but I left it out there. So I got to correct it now. Okay. Again, I want to look at numbers that are similar here. and I've got an n factorial and an n subtract 1 factorial. I got an n subtract 4 factorial and an n subtract 5 factorial. These are close and these are close. And I guess 5 factorial and 3 factorial are also close. So I want to break down the higher of the two that are close to each other until I get the next one. So I'm going to start and break this down. I'm going to take my n factorial and break it down so that these two here will simplify. I'm going to write that as n times n subtract 1 factorial. I know that that's going to cancel now with the n subtract 1 factorial on the other side. If I look at the n subtract 4 and the n subtract 5, again, you always break down the larger number. So I'm going to write n subtract 5 factorial here times 5 factorial. I'm going to write that as 5 times 4 times 3 factorial. There's my 3 factorial in my numerator. That's why I stopped at 3 factorial, because I know that can cancel now. Now, the n subtract 4 is larger than n subtract 5. So that's why I want to break down n subtract 4. So I'm going to start with this one. I'm going to break it down until I get to n subtract 5. So I get n subtract 4 times n subtract 5 factorial over n subtract 1 factorial. Now you should be able to see here now that a lot of the factorials will cancel. N subtract 1s will cancel. My 3 factorials will cancel. My n subtract 5 factorials will cancel. And all I'm left with here now is simply n over 20 times n subtract 4. Which gives me n times n subtract 4 over 20. And I'm done. I wasn't asked to solve for n here, folks. What I was asked to do was express as factorials and simplify. I've simplified it. There's my answer. Important thing here is breaking down the factorials, right? Always start with the larger one and break down until you get the smaller one. Example 3. Solve for n. Okay, if we look at what we have here, we got the C of n choose 3 and the C of n choose 2. From here, we can see that n has to be greater than or equal to 3. And from here, we can see that n has to be greater than or equal to 2. So I guess the overall restriction is that n has to be greater or equal to 3. So we need to keep that in mind, that n has to be greater or equal to 3. So if I solve this for n and I get a number less than or equal to 3, this doesn't work. I have to ignore those answers or reject those answers. So let's start simplifying here. I got n factorial over n subtract 3 factorial times 3 factorial equals 3 times, now the p of n choose 2 is n factorial over n subtract 2 factorial. Now we're going to start breaking things down here. I got n times n subtract 1 times n subtract 2 times n subtract 3 factorial over n subtract 3 factorial. And I stopped at n subtract 3 because that's what my denominator contained. And I can cancel these. Times 3 factorial equals 3 times, and I need to do the same thing with the n factorial and the n subtract 2 factorial. I break down the n until I get to n subtract 2. So I get n times n subtract 1 times n subtract 2 factorial over n subtract 2 factorial. These will cancel. These will cancel. That eliminates my factorials. And I want to get rid of the factorials, and I've done that now. All I need to do now is simplify what's left. I end up with n times n subtract 1 times n subtract 2 divided by 3 factorial, which is 6, equals 3n times n subtract 1. Now remember, n has to be greater than or equal to 3. We need to keep that in mind at the end here. If we want to solve this for n, the best thing to probably do is simply multiply through by 6. Let's multiply through by 6 to get rid of the fractions here. The big and cross multiply is the same thing, but let's multiply through by 6. I'm going to get n times n subtract 1 times n subtract 2, because the 6's will cancel, equals 18n times n subtract 1. Let's see what we get. Now we're going to get n squared subtract n times n subtract 2 equals 18n subtract 18n squared subtract 18n. Now let's multiply the left side here. I'm going to have an n cubed subtract 2n squared subtract n squared plus 2n equals 18n squared subtract 18n. And we end up with a cubic here. Now let's come up here to the top of the page and let's finish this. Hopefully we'll have enough room here. So I have n cubed. Now let's think about my n squares here. Let's do all this at once here. I got a negative 2 and a negative 1 is a negative 3. Subtract 18 is a negative 21n squared. I have a 2n plus 18n is 20n. Equals 0. So here's a cubic equation. I want to solve for the three values of n, because there are three solutions for n, of course. The quickest solution here, of course, is to remove a common factor of n squared, subtract 21n plus 20 equals 0. So I got one solution for n already. N is equal to 0, right there. Now all I need to do is factor, and hopefully it factors, what I've left inside the brackets here. Let's check it out. n, 20, and 1. I got a negative 21, so both of these would have to be negative. And I get n is equal to 20 for another solution, and n is equal to 1 for another solution. So there are my three solutions for n. But we need to remember that our overall restriction indicated that n has to be greater or equal to 3. Because remember, this value of n got to be greater than or equal to this value here. So that immediately tells us that we need to reject, the two solutions, n is equal to 0 and n is equal to 1. They need to be rejected because they don't fit our overall restriction. So we need to reject them. So the only solution seems to be n equals 20. Now let's double check it, see if we get the correct answer here. If we double check n is equal to 20, let's see what we get. We got the C of 20 choose 3 should equal 3 times the P of 20 choose 2. The C of 20 choose 3 is 1140 equals 3 times the P of 20 choose 2, which is actually 380. 380 times 3 is 1140. So yeah, it does work. So I just checked it, and n equals 20 does work fine. And I've solved that now for n. Okay, let's have a look at a couple of more examples here. Example number 4 is a multiple choice question. You may want to try this one on your own first. The C of A choose 3 is equivalent to what number? I'll let you try it. You can pause the recording if you wish, and then start recording up again. Okay, let's do it. The C of A choose 3. The C of A choose 3 is going to be A factorial over A subtract 3 factorial times 3 factorial. That's the C of A choose 3. Now looking at the 4 possible answers there, which one might work here? Well, you may want to try each and every one of them. But I think I know the solution from looking at it. Now you would probably try all of them, so let's do that. This will be A factorial over A subtract 3 subtract A factorial times 3 subtract A factorial. That's going to give us A factorial over 2A subtract 3 factorial times 3 subtract A factorial. Not even close. Definitely not A. Let's try B. I'm going to get A subtract 3 factorial. Right away my numerator doesn't match up. So I'm thinking that is not this one either, because of the fact my numerator doesn't match up. But I'll continue with it. A subtract 3 factorial times 3 factorial. I get A subtract 3 factorial over A factorial times, A subtract 6, right? A subtract 6 factorial times 3 factorial. That doesn't match either. Let's try it. C, 3 factorial over 3 subtract a factorial times a factorial. Ah, that was close, but it doesn't match. And finally, let's try D here. A factorial over a subtract 3 factorial times a subtract 3 factorial. Let's simplify it. A subtract 3 is 3 factorial times a subtract 3 factorial. Compare the two, you can clearly see that D is indeed the correct answer, isn't it? The correct answer is D. Number 4, which of these is not equivalent? N plus 2, choose n subtract 1. Well, n plus 2, choose n subtract 1. Let's simplify it. That is n plus 2 factorial over n plus 2 subtract n subtract 1 factorial times n subtract 1 factorial. That becomes n plus 2 factorial over, I got n subtract n is 0, 2 plus 1 is 3, times n subtract 1 factorial. That's what that simplifies to. Clearly, A is a suitable answer. But it says which is not equivalent. So because which one is not equivalent, then I can't circle A, because A is equivalent, of course. So let's get rid of my circle at A there, because that one is equivalent. Which one is not equivalent? The C of n plus 2, choose 3. That will be n plus 2 factorial over n plus 2 subtract 3 factorial times 3 factorial. That's n plus 2 factorial over n subtract 3 factorial. Sorry, n subtract 1 factorial, my apologies. N subtract 1 factorial times 3 factorial. Yep, that's the same as this one. So the answer is not B. What about C? The P of n plus 2, choose n subtract 1 over n subtract 1 factorial. Well, the P of n plus 2, choose n subtract 1, will be this. N plus 2 factorial divided by n subtract 1 factorial divided by n subtract 1 factorial. When I multiply this by the reciprocal, n plus 2 factorial over n subtract 1 factorial times 1 over n subtract 1 factorial, I'm going to get n plus 2 factorial over n subtract 1 factorial times n subtract 1 factorial. That one is not correct. So which one is not equivalent? The answer is C. D, by the way, if you do it, will work out fine. Okay, that ends this lesson. Let's have a look at the key ideas. To solve or simplify equations with expressions involving the C of n choose R, or n choose R, you simply use your knowledge of algebra and the following formulas. And there are your 3 formulas for the C of n choose R, and the P of n choose R. Just use your knowledge of algebra, that's all. And your knowledge of factorials as well. And you should be able to simplify any expression involving the C of n choose R. And that ends this lesson.